All right, guys. Good afternoon. I have been trying to touch base with those persons who I know are supposed to be here, and oh, wait, one is here. I, all right. Let us see what can happen now. I know one more supposed to be here. Well, two more I know supposed to be here. That will make it five. One said that she's not doing it, and there are about three other students that we need to see what can happen in order for the class to be viable. So if these persons don't turn up, we'll have to have another conversation. But in the meantime, let me welcome you to the course. Technically, it's going to be a fast tracked offering. And for those of you, well, all of you would have gone through the course before. So what I'll be doing really is going through some of the troublesome areas. One of the things that I recognized in marking your scripts, that none of you, for the most part, maybe just one student, I believe, attempted the differential equations. So what I'll be doing is, yes, going through the topics, but I'm going to be selecting different areas to go through, the areas that I know are troublesome, so that when you go into the exam, you can answer those questions. Most people are very comfortable with Newton-Raphson, so they go into the exam and get their 6 marks for Newton-Raphson. I will not start with Newton-Raphson today. Or maybe I will, because it will take a shorter time for me to complete it. But I know people know how to do Newton-Raphson. Newton-Raphson is so well organized that most students go into the exam and say, okay, I'm going to do Newton-Raphson, I'm going to do multivariable functions, and those are the only 2 questions I'm going to be doing. And the truth of the matter is, those 2 questions alone, based on the distribution of marks, would not have allowed you to pass the course. So some of you came very close in passing, and some of you were a little far off in passing. So mine is going to be the task to gear you into some areas where I know will be very critical for the success in this course. So I will just take a break now and hear what it is that you have to say to me before we hit the ball running. Any questions, any concerns, any comments?
Sir, is it possible can say like our paper?
Can you speak up again? Sit again.
Is it possible can say our paper?
All right, hold on now. Me now hear you now.
Is it possible can
Hold
say
on, let
our
me get a
paper?
headset because I'm not hearing at all. I know you're speaking, but I'm not hearing you. Hold on. You have to speak up. Somehow I can't find my headset. I can't find the headset. Can you speak up for me, please? Is this Rami? You're saying something about field paper? Hello? Is anyone hearing me? Okay. Oh, absolutely. Sure, you can see your paper, but you'll have to route it through the assessment services unit exams. And you're always free to have a look through your paper. And you're also free to have your paper be remarked. But also be very aware that when the paper is remarked, it can go either way. It can go up or it can go down. So I have seen, not that I'm discouraging you from doing it, I always encourage students to get a remark of their paper, should in case they feel dissatisfied. But but also be aware, if for example you had a 50% exact and you believe that you got an A paper, but when your paper is remarked, you end up with a 48 or 49%, it means that that second remark grade is what it's going to be. So it means that you will no longer have passed the course, you know, failed. So I'm saying when you do the remark grade is going to be final. So if you got a 50% and person remarked the paper and you end up with a 75%, it is a 75% that you have. So it goes both ways. But sure, contact the assessment services unit and you can have a look at your paper. I have no problem for that to happen. They will contact me and I will make the arrangements to get the paper across to them so they can do the stuff. All right. Are there any other questions, please, before? Hello, 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 hello.
No, sir, there's no other question.
Okay, thank you, thank you, thank you, thank you. Teacher had a class this morning in here, so teacher is already heavily spent for today. So I don't want to come here today to be struggling seamlessly. I don't want to be struggling at all. I want to be able to, I want to be able to get through our task and to get through our task pretty quickly. All right. 138. I need a headset. Where's this headset, Laura? Hold on, I'm trying to bring something up for you. Come on, come on, come on. Where is this headset? Hello?
Yes, sir.
All right, good. All right, so sorry, another student is touching this. Just give me a second. All right, so I'll just wait until he comes in. All right. Is he here now? Yes, yes. All right, so welcome. All right, so two students, Maurice and Davio, should be here, but I know Maurice came in earlier. Actually, he's going to rejoin, but I got a message from Ramesh to say that Davio sends our apologies. And there we have about 3 more students who should join us. One says that she's not doing it. So let's go. I need to have a conversation with you. I need to have a conversation, a serious conversation, in that it's a fast track class. And based on what it is that I've marked, there are areas where I know you guys are strong in, and there are areas where I know you guys are very, very weak at. Newton-Raphson is one of the strong areas. Newton-Raphson is one of the strong areas. I give you any question in Newton-Raphson, and I know you guys can do. So what I'm going to be doing is just going through Newton-Raphson pretty quickly to boost your confidence, and then I'm going to start with an area that I know is troublesome. And I want to start on that troublesome area from early, because it's going to come in that troublesome area is going to be differential equations. All right. So most of you, and Newton-Raphson, you have to, and Maclaren's expansion, sorry, is another troublesome area. And especially when you're given a function that is logarithmic or exponential, and it unfold. So I want to spend some time on those. So let us just develop again, redevelop this concept of Newton-Raphson. And I'm going to ask that if you're in doubt for anything at all, just stop me and ask me so I can provide some clarity for you. All right. I hope that you are hearing me. And I hope that yeah, okay, all the way up the volume, that is. All right, so the formula for Newton-Raphson here is going to be x subscript n plus 1, and it's going to be equals to n x of n minus f of x of n over f dash x of n. Now n is going to be 0, 1, 2, 3, so forth and so on. So if n is 0, I'm going to have the first iteration x1. The first iteration is going to be x of naught minus f of x of naught over f dash x of naught. The second iteration will be x2 is going to be equals to x1 minus f of x1 over f dash of x1, so forth and so on. So this one here is giving you the evaluation of your iterations. Your iterations is just a guess. It's a guess. It's an initial guess of having of going somewhere with the expectation that you're getting closer and closer to where it is that you're going. Getting closer and closer to where it is that you're going. Now, for example, I keep saying, let us try and develop a situation where we are doing hide and seek or lost and found. A case where this is something that the police officers could actually use in converging on a suspect. Funny enough, this morning while I was in another class, I gave them some work to do, and I was looking through my phone and went on Google, on YouTube, and I saw where
I think in the African countries, they have a lot of land, so the houses are huge, and you have also a lot of robberies. So people are going through their electronic gates, and they're driving up, and so be it. A car is driving behind them, and gunmen are there, and they're trying to hold them up. And oftentimes, these persons who are being robbed will try to take matters in their own hands by reversing, or driving away, or as I saw in one case today, challenge one by pulling his firearm, and the man then run left the car. And I'm saying this is a good example of iteration, because they ran in different directions. They left the getaway vehicle. As an eyewitness to the crime, I can say he's short, he was wearing a white shirt and a black pants. And he went in that northerly direction. Now, the time I responded to you, he could have been on foot, could have been about 20 minutes away. So he could either be in the bushes or he could have taken the straight path. So I'm now going to be redoing control and say, here the plan. I am at John R. Wong. And this person went straight up Trafalgar. And I may say, okay, but up Trafalgar, say, well, him can turn off on Braemar, him can turn off on Worthington, him can turn off up Little Musgrave, him can turn off all the places. So there are several different turnoffs. One of the things that I can do, I can ask radar to send a car on each of those turnoffs, coming back to the main road. That's exactly what we're doing here with the iteration. I have my curve, I have my exact route, which is where I want to get to. This is where I want to get to. I don't have any interest but finding where my exact route is. Me want to find my loved one, me want to find a boy who break into my car because me want back my keepsake. I want back my keepsake. All right? My initial guess. So this is where everything started. This is where we defined him. I'm guessing here. What I'm doing, at my point of initial guess, I'm going to be drawing a tangent to the curve. So why are we doing a tangent to the curve? When we do a tangent to the curve, it means that we're finding our differential. And see in the formula here, your f dash of x is actually your differential. It is actually your differential. So what happens is, at my point of contact, I am drawing my tangent because I'm finding the differential at this point. Where that tangent cuts my x-axis, I'm doing my extrapolation to the curve. So I'm finding my new iteration. So I'm taking a guess after my initial guess. That's the plan. If I were to come here, it is going to be closer to the root, closer to this root. And at this point, again, I'm going to define the differential. I'm going to be drawing a tangent to the curve. Where it hits the curve, I'm going to be extrapolating to the curve. I go up here. This is going to be my third iteration. See, it says f of x3, my third iteration. I'm doing the same thing here. Finding the tangent to the curve. Draw my line where it cuts the x-axis. I'm drawing. I'm extrapolating to the given curve, f of x. This is my fourth iteration. My fourth iteration. And still get closer to my exact root. If I were to draw a tangent to this curve and come here, what is going to happen is that I'm going to get the value of my root. If I do as many iterations thereafter, I'm going to get this exact value. Why? Because I've already reached my root. So think of it this way. When the glass is full, it no matter how long you put it under the pipe, it's not going to be any more fuller than it is because you've reached your maximum point. So if after 2 iterations, I get my value, and I do the 3rd iteration and I got the same value, trust me, the 4th iteration will give me the same value, the 5th iteration will give me the same value, the 6th iteration will. So as many times as you go, I'll get the same value. So you know where your endpoint is. So which is why we're saying to you, when you reach 2 iterations that give the same value, you're done. Because if you go to another iteration thereafter, you're going to end up with the same value. And you go to another iteration after, you're going to end up with the same value. So once it is that you get 2 iterations with the exact value or the same value, sometimes it's not exact. Sometimes they will say to you round off to 2 decimal places. The decimal places are not exact because when you work up to 4 decimal places. However, when you round off to 2 decimal places, you may get the exact value. You stop right there. Any questions?
No, sir.
Right. Very important so you understand now. Let's just look at this question. It says, show that the equation f of x is equal to x cubed minus 3x minus 4 has a root alpha between 1 and 3. Has a root alpha between 1 and 3. So you know where the crime has occurred, and you know the period. You know that the crime occurred between here, so between 1 and 3. So you can't go out. So your value, your solution can't pass 3, or it can't be less than 1, because your value is going to be between 1 and 3. Your value is going to be between 1 and 3. So what is happening here? It says to use Newton-Raphson, correct to 3 decimal places to find the next 3 approximations. Taking 2 as a first approximation, x1. So they gave you x1 and they asked you to find the next 3. Where are you going to stop?
F4.
Very good. Excellent. 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 And this is why I'm saying to you, I know Newton-Raphson is not the problem, but I just want to do this to just whet your appetite, because I soon finish it. Very nice. X4. So remember, if they never gave us this part, taking 2 as the first approximation, remember what Sir says to you? Just add the 2 limits here, divide it by 2, and you're going to estimate what your first iteration would have been. So 1 plus 3 is equal to 4. 4 divided by 2 is equal to 2. So we are guessing that our first iteration starts at 2. If that iteration is less than 2, your values will go down. If the iteration is more than 2, your value will go up. So you're starting at the midpoint of the set of values. You're starting at the midpoint of the set of values. All right?
So, sir, instead of add and divide by 2, you could just subtract.
What if I've given you 2 and 7? 2 and 7, I'd have to add 2 plus 7, 9. So my midpoint is going to be 4.5. So my x1 will be 4.5. But if I said 2 minus 7, I'm going to get 5.
Oh, say, okay, okay.
So you're going to add them and divide by 2. All right? Now, and another example is if I had between 1 and 10, if I subtract 1 from 10, I can get 9. But if I add 1 to 10, I'm going to get 11, and 11 divided by 2 is 5.5. So 5.5 is way far off than 9. And let us just stop there for a minute. Because if we make an initial guess that is too far off, you know what is going to happen? We're going to have way too many calculations that we're not going to get the exact root. And especially if this question says to the 3 iterations, when we reach a third iteration, when we reach a fourth iteration, sorry, iteration 3 and iteration 4 will not be the same value. So you know that you'll have to go on. And the only reason why you'd have to go on is because you did not follow the instructions. So if they never gave you the first iteration to be 2, you'd have had to go and add 1 plus 3 to give you 4, and 4 divided by 2 to give you 2. If you start at 1 and do the other 3 iterations, you will not get the full marks of the question. And trust me, as somebody asked about the marking of the thing, how I mark the papers, I didn't mark for answers. I marked for your methodology. So some of you question very wrong. Or some of you get like a 3 out of 7 and 4 out of 7 for the question, because at some point in time in the question, I was able to see the method coming out, right? So someone might say, no, sir, you're too generous with giving 3 out of 7 for this. It should have been 1 out of 7 or 2 out of 7. All right, so, and I did it right across the board. All right, so just to let you know. So let's go. So we need to look, we know what our x1 is. Our x1 is going to be 2. Our x1 is going to be 2. See here, our x1 is going to be 2. So the second iteration now is going to be, our x2 now is going to be your x1 minus f of x1 over f dash of x1. If your differentiation is weak, you may have problems. So remember, you have to differentiate the function. In the exam, some people never differentiated the function. They just went ahead and substitute the function into it. Now I'm saying, how could we do this? Is it exam condition, exam stress? Why is it that you didn't do what it is that you're supposed to do? So remember, you have to differentiate the function. Remember, in the denominator of the fractional aspect, there is f dash of x, suggesting that you have to differentiate. So it's going to be 3x squared minus 3. 3x squared minus 3, which is right here. So what I'm saying to you is that now that I have the differential right here, and I have my original function here, I'm saying anywhere in the function now I see x, I'm going to put 2. Why 2, sir? Because remember, you're evaluating f of x1, and x1 is 2. So you're evaluating f of x1. So anywhere in the original function x you see, f of x you see x, you're going to put 2. The same thing, anywhere in the differential you see x, you are going to put 2. So work with me. In the original function given, see it right here. So that up there is the same thing as this one here. Anywhere I see x, I'm going to put 2. So this is going to be 2 cubes minus 3 times 2 squares. Sorry, 3 times 2 minus 4, which is this. So let's go. 2 cubes equal 8. 3 times 2 is 6. 8 minus 6 is 2. 2 minus 4 is negative 2. Similarly, anywhere in the differential you see x, we are going to substitute 3 times 2 squares minus 3.
That's 9.
And that's going to give you 9. Very good. So now I know the values here to substitute. Very good. The values here to substitute. So what it's going to be is 2 minus up here, so we have negative 2, down here, so we have 9. See it right here, so I'm just substituting it into the formula now, into that formula. And I'm going to evaluate it, and I'm going to get all of this 2 minus negative 2 over 9. But these two negative numbers, when they bombard each other like this, they become positive, because there is this negative number being multiplied by another negative number. It gives you a positive number. So what you're going to end up with is 2.222. They did ask for 3 decimal places, so I'm working with 1 more decimal place. They asked for 3 decimal places, so I'm working with 1 more, so I'm working with 4 decimal places. Whatever number of decimal places they ask you to work with 1 more than that. All right? And again, now that I have my first iteration, I have a starting point, I have my first iteration. I'm going to move on with the third iteration. So that was my second iteration. The first iteration was a 2. My second iteration is what I just evaluated to be 2.2222. My third iteration now is where I'm going to substitute my second iteration into my function. So anywhere in the f of x, I see x, I'm going to put 2.222. What is f of x, sir? I just typed something but I'm not seeing it. I just typed something. The modification is allowed because the selection is locked. What do you know? All right, hold on. All right. So recall what my original function is there and here. All right. So anywhere in those functions I see x, I'm going to substitute all of x2, which is 2.222. Right? So this is the original function. So anywhere in this function I see x, I'm going to put 2.2222. See here, 2.2222 cubed from here minus 3 times 2.222 minus 4. When you put all of this into your calculator, you should get 0.307. Can you try that for me, please?
Yes, sir.
Yeah, man.
Mhm. Okay. And then do me a favor now. You know what f dash of x is. Substitute 2.222 into f dash of x and tell me what you get, please, and times.
11.8145.
11.8145. Let me see if I can write it. Come on, go through my notes. 11.8145. Very nice. So what I'm doing on my x3, I'm going to be putting my 2.222 over what I got for my f subscript f of x2 over all of my f dash of x2. And then I'm going to evaluate this. Put it on calculator and tell me if you agree with me with the 2.1962.
Yeah, look right. Yeah.
Sorry, and you're talking and it's muted. Next up, how you feel? How you feel? You agree?
Look at this.
Was that
Yes.
yes? Oh, okay, good, nice. And then now, we need to go to the fourth iteration. For the fourth iteration, I'm gonna just copy this recall. And then when I copy that recall, I'm gonna ask you to do the fourth iteration for me. The fourth iteration is, I'm gonna need about 3 minutes to do the fourth iteration. You know what your x3, your x4, your x3 is? Your x3 is 2.1962. Go ahead and do the iteration for that fourth one for me and then come back to me. I know you know how to do this. As I said before, on a whole, I know you guys know how to do this. I'm not worried at all about this. I know you know how to do it. So work on the fourth iteration. Give them about 3 minutes to do the fourth iteration, and then I'll come back and double check with it. So if you don't get it right, you will still see it. So you don't have to be too bad about it. All right, 3 minutes.
Sir, good evening. Mr. Sean, do you hear me? Hello. Mr. Sean.
In probably step way now.
Oh, all right.
Anybody finish?
Yeah, man.
All right, good. What you got for your fourth iteration?
What you want the final one?
Final answer. Just give me the final answer.
0.9926.
0.9926.
Yeah.
For the final answer, Rush.
Based on workout, yeah.
All right.
I'm good.
Look at. We get this. We get this. Somebody get this.
Get 2.0721.
And my calculator must say now work then.
What you get, Maurice? What you get, Ramesh?
Go back in our history. Book 3 says x cubed minus 3x, right? Minus 4.
That's what I get. 2.1958.
Let's see next one. Long answer. Wait. Let's wait. 3x. Oh, I must say the mistake. We have 3x without no square. All right.
Nestor,
Right.
look and tell me if you see where you went from. You got 2.0 something. You got a 2.09, Nestor.
Yes, sir.
Look to see if you see where you went from.
2.9.
Sir,
Mhm.
I'm not getting an 8 from mine. 2.1950, me get.
Who?
Yes, sir. I'm saying.
Sir, I'm not see where you get that 0.00 4.
4.3?
Yeah, man, because my thing I know why.
You never
I
feel
know
it.
why not. Yes, man, I did because it got 10 something. It got 10 to the
You get 4.319. I just got 4.3 down.
10 to the cube, it got negative cube. That's why you carry it over to the 3. Yeah,
Right.
that's right.
Ramesh, what
That's
you
right.
saying now? Let's see, Ramesh.
Sir, I was saying I got 2.1950.
That is fine. Or you don't get an 890, but you get 0? Right here, sir?
Yeah. Yeah.
That's
Weird.
all right. Question: did you use 4 decimal places or 3?
Huh?
How many
Repeat, sir.
How many decimal places have you been using? 3 or 4?
4.
And you got this here. You got the same answer as mine in blue.
Oh, not the first one, sir.
What you got for the first one?
0.0130.
Right here, sir.
Yeah.
Check it again, please. Check it again now for me.
So me get 11 now.
Nice.
4, 6, 9. It better be 9 because of 9.
Ooh.
Crystal.
Very nice. Ramesh, where you get? You get it now?
Yes, sir.
Remember, you know,
Show up on the calculator. 4.319.
319 times 10 to the negative 3.
Yeah.
All right. So you have to be able to convert the 10 to the negative 3 into 0.004319. So moving from standard form back to decimal place.
Yeah.
Right? All right. So it will be the same thing as 4.319 times 10 to the negative 3. So this is just in standard form. That's just in standard form. All right. And we're converting the standard form back to the decimal place. So negative 3 means that you have a 0 in front of. Had it been positive 3, the zeros will be behind. So positive the zeros are behind, negative the zeros are in front of. So you would know then to the 2.1958, right? Ramesh, because you're getting 0. All right now?
Yes, sir.
Reese, how you stay? Yes, sir. You all right, Mummy?
Yes, sir. Yes, sir. Yes, sir.
No, guess what now? They promised me that you're not going to move out of any of these very quickly run sessions. Without full some understanding. Talk to me, let me know. We're doing this course in the summer here to get through the course in the summer. We're doing a course in the summer to get through the course in the summer. If this were to encourage you at any point in time, last summer I had 12 students. A few of them needed to graduate. I mean, I sat in that graduation exercise and I saw some of those students who I know had calculus 2 alone outstanding, and they were able to meet the graduation. I felt proud. We are going to sit here. It's a small group. We're going to work together. We're going to help each other. We're going to get past this. Work with me. You're good to go. All right. So
Yes,
let's
man.
go.
Yes, man, sir, because after this semester, I eat that, you know,
I eat
done,
that.
me
Done.
done.
And I'm going to say to you, you and a few others, Rashid, why I asked Mrs. Campbell to go ahead and just start a group, because I know you guys need to just finish off, and I really want you guys to finish off.
Amen.
You know, to be honest with you, if you ask me, I had a class this morning. Me tired. I tell you straight up. I had a class this morning, tired, and I wouldn't necessarily want to take on another class. And I said, no, I don't want anybody to be left back in the system because of a math course. So this is why I'm pushing through to do it. So when I come to class, I want to feel your energy so that I don't feel lethargic. All right. So going good so far. So thank you. All right. So
one thing, sir, sorry.
go ahead, Pop.
I'm gonna miss him next Saturday, you know.
Man,
I travel
look at
from
that.
my grand. Oh, you see it. All right,
Let
cool.
me see it, man. Cool. Just be safe here.
Yeah, man.
All right. So we have that. So I'm saying to you, you see that to 3 decimal places, the result is of alpha is 2.196. So when I round off, this is my decider. And my decider here is greater than 5. So that means I'm going to add 1 to this one. So I'm going to get 2.96. But if you look up top, when I round this off to 3 decimal places, I still get the 2.196. You see the point I was making earlier? That the value is exact when I move to 3 decimal places. If I were using 4 decimal places, the value is not exact. So that's why the man them say to 3 decimal places. So the man them know. So that's why the man them say, you know what? Run top to 3 decimal places, then we get the exact value. So it is important that whenever they ask you to work in, to give your answer in 3 decimal places, you always work one more. Give them 4. Because if you had worked in 3 decimal places, when you round off, you would not have gotten the same 2.196. You maybe get 2.195 or 2.197. All right. So just work ahead of that. All right. Very good. Excellent. Any questions? I know how to do this, you know. I know how to do this. This is not my concern, honestly. I'm being very frank with you. Everybody here, with the exception of one person I didn't teach, I know that this is not your concern. I'm going to step away for 2 seconds but I'm going to give you this one to work on. If it means that you need to talk to each other in the class, it don't mean nothing to me. But I want to work through this question, then I'm going to give you 2 more questions. Then again, break and have a conversation about the classes on a Saturday. And then we're going to come back because I'm wrapping up Newton-Raphson done, you know. Newton-Raphson is finished. I know you know to do it. So work on it for me, please. I'm going to give you about 3 minutes because it's only 2 iterations I want. So I'm going to give you about 3 minutes to do it. All right? So start for me.
So, Sean, are you there? Oh, all right. Well, go on them work you have to do?
Example. If you go on.
Oh, okay, all right.
Holy State.
Not finished.
Okay, all right, no problem.
When we're going up to 2 iteration, x3 we are going to know so. Sashan? My check 1, 2.
How you stay?
Me didn't mess up, me I did it over. So
All
finish.
right,
Yeah.
no problem, no problem. Take your time, take your time.
Good afternoon, sir.
Afternoon, Maurice, what on? Look how long me call you now.
Yeah, man.
You're not finished from me.
No, because I'm up on the road still. I said you did see my email, sir.
I saw the email, but because I saw you,
Yeah.
I never know that you're going to join. Because I saw your email, I thought everything sorted out. Anyway, what on?
No.
Um,
No, but
tell them say you in a class and it's been recorded. So all of that word a while ago got recorded in my class.
yeah, I just indicated to the person.
Yeah,
Sorry about
right.
that, sir.
Yeah, man. Cool.
So I was asking if the all right, this Word document, you would send it to us?
Yeah, man. I do after each class.
All right. Because right now I just able to glimpse it sometimes. So I would be trying to catch up.
Yeah, man. I would send it normally as a PDF document in the WhatsApp group. What I'm gonna do, I can, Nestor, what you say? Can set up a WhatsApp group for me, Nestor, or whoever? Who can set up a WhatsApp group for me for this fast track? Anybody? Somebody? All right.
All right, sure.
All right. Thank you, Rash. All right. So we're gonna set up a WhatsApp group so that at the end of the class I can send you the document in the WhatsApp. That's what I normally do myself, Maurice. At the end of the class, I just put this stuff in the WhatsApp group.
All right, thank you very much.
No problem.
So it's just this you will be going through today?
This is an easy one. Now, hear me out, no, Maurice. These other students that I have here are students that I had in the past. So I know where their strong areas are and I know where their weak areas are. I don't know where you are as it relates to this. So I'm pretty much finished with this because this is all that there is to it now for the Newton-Raphson. But I also have to take your level of understanding into consideration. So you no need to let me know how you feel so far. But you say you're on the road, so let me just continue and then you look at it afterwards and where you feel uncomfortable, you can just message me.
All right, okay, I can tell you from now is sometime is last year I did it. So I know a lot of the things not so fresh in my head.
I know.
Yeah.
That's why I said what I said.
Yeah.
All right, so if you can follow through, when you look over this stuff, if you're not seeing it so well, you can just drop something in the chat because this group is going to stick together as a little family until we get past this hurdle. Until we get past this hurdle. All right, let me just. There's somebody who's supposed to. All right, you can mute. Thank you, and just listen on. There is somebody who I was just talking to, who is supposed to be joining me. Okay, so why didn't no come on it? I want to have a conversation. Or maybe them bugging on, waiting on you. All right. So I did ask one or two of you how, oh goodness, I didn't touch base with that student. Oh Lord, she's going to cost me. Where did she touch base with me? What's up? How, all right, so the Saturday to run 4 hours on a Saturday at this hour of the evening, kind of rough. I consented to it yesterday when I got the call because I too got the call yesterday to start the class today. And I say, no, what, set it on because I want to make sure that the students can come together first for the first class and we can streamline ourselves. Okay, so she's trying to join from her laptop. Okay. So having, from 8 o'clock to 11:30 with a class, I want to know your availability. Can we do 2 hours on a Saturday and 2 hours in the week? And if so, which day of the week? I want a time that is going to be conducive to everybody. If it's not going to be conducive to everybody, but I forgot to sleep on a Saturday because I don't want anybody to miss out. So what I want is, can you suggest another day of the week? Let me see if I'm available. So we can just run 2 hours on a Saturday and then the other 2 hours. All right, somebody's responding.
Is that in the day or in the evening? My shift changed now, sir.
It changed. Okay, so what time is good for you, Rash?
Evening, because I started my old position, so I'm gonna be working from probably 8 to 4 or 9 to 5. I don't know 2, but I have class Monday 5 to 7 and Wednesday 7 to 9. Probably the other way around. Yeah, that right. Yeah, 5 to 7, then 7 to 9.
All right, so that means Monday and Wednesday can't work. I was hoping that Wednesday could work. Monday and Wednesday can't work because Monday I teach 7 to 9 and Wednesday 5 to 7. And those are the 2 times that you have class. No, you are free at that time when I have class, and when you have class, I'm free. So Monday and Wednesday out. Which other days, guys? So Monday Rashid goes, I'll come into you next about. Monday Rasheen goes 5 to 7, but I go 7 to 9. So Monday, Wednesday, oh, so I'm hearing this as a Friday. What the rest of you say? Friday can work?
Go to Friday too, sir.
All right, nice. Maurice, how Friday stay for you? All right, I guess he's engaged.
Friday is a big sacrifice, so me work with it.
Okay, yeah, man. Guess what? It's going to be a sacrifice because at the end of the day, we're going to get through with this. We're going to get through this. Just work on. The truth of the matter is, Rash. The truth of the matter is, maybe I have to go. Maybe when we talk about only doing 2 hours on a Saturday, maybe I'll do the same 2 hours on a Friday that we are suggesting. I may have to end up doing either 3 or do back the same 4 hours on the Saturday just to complete the syllabus because we are going to get through with this. I'm saying this to say to you that this is now July, so we have 1, 2, 3, 4 more Saturdays in July, and 4, 5, 6, 7. So we have 7 classes, 8. So today will be the 8th class. 5, 6, 7, 8. That's 32. I have to go get at least a 45 hours with you. So 32. So 10. I need another at least 12 hours with you. Anyhow, so let us put in a Friday. So I will say to them, let us put in a Friday because I'm going to need someone. It's a 6-hour course, and I'm trying to do it in 45 hours. All right. So I may have a challenge, but if we together work, we should be fine. All right. As it is just now, maybe Maurice is the only one that I may have to pull out to go through some stuff since he last did this course over a year ago. But for the rest of you, I know exactly where you are, and we should be able to overcome this. All right, so I'll speak back to them and ask them to create a class on a Friday for me. Yeah, on a Friday. 5 to, we could try 5 to 9, so I can, yeah. Oh, and you see what is also going to be important, students? I'm going to give you out of class session. So one of these days I may say to you, here's the plan. Today, Saturday, I want to log on and I have these series of questions that I want you to go through. So we're going to do a lot of work on our own so that we can catch up. I'm trying different avenues. It's a fast track class, so I'm trying to see how quickly I can get through the stuff. So I'm trying different avenues in order to get on, all right? And whenever having conversations about the stuff, or any questions, drop it in the group, past papers, drop it in the group, so that Maurice, who is not originally part of your group, will be able to catch on to the information. There's another student that I'm trying to look for as we speak, who did reach out to me to say that she needs to do this stuff. She wasn't a part of your other group, so maybe Maurice will know her, maybe not. So I'm trying to find her to tell her that the class is formalized now, but all right, guys, Rasheen is asking if we could send a number so that he could add us to the group. When that is done, we can I can just take myself out of the other group. I didn't take myself out of the other group yet because I wanted to formalize this group. So I can do that now, in time now. All right. All right. Okay, is this her? Is this her? All right, I'm hoping that this is her so I can. Should I know how to? Please do not ever check this is kind of, so this is her. All right, let me just go back now to the original message. And then All right. All right. Let me go back to. Let me go back to. All right. That's what I got. 2.5027. Tell me that's what you got.
Yeah, yes, sir. My did mute, sorry. 2.507. But hold on. Right? It's to the it's a X2, X3. Oh yeah, right.
Okay.
Yeah,
Rush,
man.
Rush, do me a favor.
X2.
Rush.
Yeah,
Five
yes, sir.
nine five 598
598
0961.
0961.
Repeat
All
it for
right.
me.
5980961.
Yeah, add that person to the group also, please.
Cool.
All right. I need to hear from the rest of you. Maurice is in transit, so I don't expect to hear from him. Nestabu, what to get? And the rest of you, tell me what to get. Talk to me. Are you still working? What is it?
Say again, Philip, please.
Sure.
Sir,
Mm.
Mr. 2.503 me put in
2.503 for which one? For the final, for the third iteration?
yeah,
Come in 1
because
minute.
it said two decimal place and I said do one more.
Yeah, true. It's a 2 decimal place. So you would get 2.50.
2.50. Yeah. The answer is 2.50. The answer is 2.5. Coming to you, Nestor. The answer is 2.50. What I did, I think I made an error by doing one more iteration than I was expecting to do. So see here, so my answer is 2.50. Sitting right here. But what I did was to do an extra iteration than is required. Let me just remove it.
Same.
Yeah. See, all right, no Rush? Not Rush.
Yes, sir.
Ramesh? All right, cool. Nestor, you also go up. See, I'm right here. That's where you want me, Nestor?
Yes, sir, I got it.
You got it now? Very nice. Okay. Remember to drop your numbers in the group so that Rasheen can create the WhatsApp group for this fast track group, please. There's going to be a whole lot of information being shared because we need to get this thing quickly out of the way. All right. Let me give you example 7 to work on. But before I give you example 7, I need to talk to you about something. Whenever you're given a question such as this, it says find a root of an equation f of x is equal to x cubed minus x minus 1 using Newton-Raphson. Please note, I'm telling you that you're not given the initial guess, so you're required to find it. Now, what needs to happen is you need to look across. Remember that exact root that we made reference to? This is page 31. You remember that exact root that we made reference to? Watch this. The exact root is I am in the positive, bam. I reach 0. Then I'm in negative. So when you're able to move from positive to a negative value, it means that you have crossed over your exact root. Or you can move from a negative value to a positive value. It means that you've crossed over your root, right? So you can't use two roots that are positive. You have to use a root that is, one is positive, one is negative. So for example, if when you try -1, and -1 is a positive number, and when you try 0, 0 is a negative number, it means that your root lie between -1 and 0. You see what I'm saying? Talk to me, no man. Sure.
No, sir. I didn't
All right.
get you.
All right. So let us look at example 7. So example 7 says, you are required to find the initial guess. So what I am doing for my initial guess now, I don't know the root, so I'm looking at some series of numbers. But I have to move from 0 to see exactly what is happening. All right? So I'm going to start with x equals 0. When I put x equals 0 into the function, 0 cubed minus 0 minus 1, it means that f of x is going to be equal to -1. When I put in 1, 1 cubed minus 1 minus 1, my f of x still works out to be negative. So I can tell you that the root does not lie between 0 and 1 because both answers are negative. It don't cross over yet. But when I move to 2 now, I'm going to get 2 cubes is 8 minus 2, which is 6. 6 minus 1 is 5. See, I get a positive 5. So I can say that I would have crossed over from being 5, 5, 5 across my exact root until I get down to a -1. So it means that I would have crossed my root somewhere right here. So I know my answer lies between 1 and 2. Can you agree with that one?
Yes, sir.
Yeah, man. And let me just go and show you again. When you look at the diagram I have up top here, I am positive, 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 positive. And when I reach my exact root here, so then I turn negative, 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 negative. Or if you read it the other way around, it's the same thing. I am negative, 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 and at some point in time, I jump to positive. So right, this one was -1. Then when I jump over, I get 5. So it means that I would have passed my exact root at some point in time. Now that I've passed my exact root, I am going to be using 1 and 2 as my roots. All right. So I'm using 1 and 2 as my root. So now, since there's a change of sign from negative to positive, then the root lies between 1 and 2. Move on from there now. So I want you to move on. So now you know what your first iteration is. What will be the first iteration? Let me hear you.
1.5.
Very good, Rash. Excellent. Nessa, you see him get the 1.5?
Yes, sir.
Very nice. I'm giving you a couple minutes. I'm giving you 3 minutes. I'm giving you a couple minutes. I'm going to step away, but I'm going to have my phone with me so I can hear what is the conversation. All right, start working, please. Start. I'm having a conversation and I'm muted. Maurice, you have not provided your telephone number. And the group has been up now a couple of minutes ago, and we need to make sure that you're able to get the the notes when the notes are sent off. So please, can you drop your number in the chat or just say it out so that we can add you to the group? Thanks. How is the still working? All right.
How much decimal place? You never saw much decimal place.
No, but leave it at. Let us try it at three decimal places. That's what it look like.
All right, we're done then.
Mm. Cool.
So,
Honest or silent? Hello?
Yeah, man, sir, I'm there.
Honest or silent? Wanna finish your question?
Yeah, my mama tell us I need it finished, you know.
Oh no, but me wait for the rest of them. I'll bump to the rest of
Yes,
them.
sir. Finish.
So Adrian. Did you say something, man? All right. Fine. Hold on. What did you get for the answer? Talk to me now.
Yes, sir.
What was the first iteration?
$1.5.
Good. And the second iteration, I got 1.34.
1.35.
All right, good. And then the next one is
1.33.
good. 1.35, 1.33. And then the
Let
other
me
one
get
is,
them. Let me get them.
wait, somebody got Nestor? How you get them?
No. So let me get them back with them. And for the first one, I get 1.33 and the second one 1.35.
Hold on.
Let me see.
So you see the first one you got, okay, the first one is 1.5. The second one you got 1.33, you said?
No, I got that for the first one.
Yeah, but the third one is also, you got that for the first one?
Yeah.
No. Remember, the value lies between 1 and 2. So you're going to add them both, divide by 2 to get 1.5.
Yes, sir. Let me get the 1.5.
Good. That means the second iteration for you then is 1.33.
Oh, okay.
Okay, and then,
Okay.
all right.
Yeah,
all right.
yes, I get that.
All right, so I got 1.35 for the second one, and then I get 1.33 for the third one, and the fourth one I got 1.32. So I guess this question, Rash, is asking for 2 decimal places and not 3. Because 2 decimal places would give me 1.32. Because this is 1.35, then 1.3. No, this would be 1.33.
No, man, sir, you can get 1.325.
No, but yeah, 1.325. Yeah. So these stats is 1.325. Yes. Yeah. So I guess it should be 1.325. I didn't say that. Yeah, 1.325. Very good. See, no, you guys know how to do this stuff. 1.325. How no feeling? I know you guys.
Sir,
Yeah.
question. For a question like this, how you know how much iteration to go up to, sir?
They will tell you, and if they don't tell you, you will make sure they will say to you. Rash asked me how many decimal places, and I said 3. So if they said 3 decimal places and they don't tell you how many to go up to, you will know where to stop, because teacher, 1 to 3 decimal places, this is 1.325, and this is also 1.325 because I'm running up to get 5.
So you will know where to stop, because if you do a fifth iteration, you still going to get 1.325 because you've reached the endpoint.
Okay.
Yeah, man. All right. That was very good. That was very good. That was very good. Let us try this one. I'm giving you one more to do for me. Number 4 says a function is given by this with x equals 2 as your first starting point. It means that this is your first iteration. Use Newton-Raphson method with 2 iterations. No, we did this one a while ago, right? No, we didn't. No, we didn't. This is the one we did. So positive root of that, give your answer correct to 2 decimal places. So now they give it 2 decimal places, all right? So work on that one for me. I give you 3 minutes to do this one. This one not hard. Start for me. And if you're having difficulties, you can talk to the members in the class and just say it out and or I will respond to you. I just want to make sure that we catch this. I may do something else that I know you guys know how to do before I move on to the difficult topics, so that I don't turn you off on day one. But I know this is a fave, and I know the multivariable function is also a fave. You guys did the multivariable function okay in the exam, but some of you, the problem is only 2 questions in the exam: the Newton-Raphson and the multivariable function, and everything else is just cutting the eye off. Can't do that. So I'm just going to get the ones I'm out of the way, so we can spend the time on the other ones that you'll seemingly not like. All right, start.
Sarah, example 4. Example
Computer?
4 we are doing?
Huh?
Example 4 we're doing?
Example 4, yeah, man.
I think we did that already.
We just did that one.
Yeah.
Look at the function. The wording may be the same, but the function may be different. Look at the function and see if I did that one.
2x
I did?
squared minus 3x minus 5.
Somebody confirm, please.
Or I keep saying.
Okay, yeah, you're correct. You're correct. All right, so we did. You're correct, Rush. You're correct. Number 5, let us do example 5. I will send you that one. Let us do example 5. It says find the solution of f of x is equal to x plus x to the, e to the x. Now remember, it's Newton-Raphson. They can give you the exponential function. They can give you the logarithmic function. They can give you any function them choose to give you. You know what to do. Extend yourself now and work on example number 5 for me, please. Please, start now.
This I might have to explain to me, sir, when we're done.
Say it again, Rush.
This you might have to explain this one to me when you're done.
All right, don't worry about it. Remember, for Newton-Raphson, x subscript n plus 1 is going to be equal to x subscript n minus, then you're going to have a fraction f of f x subscript n over f dash of x subscript n. So you have your formula. You are given a function, so you know that you have to find the first derivative. So it's the same thing that we are doing, and I don't want you to go into the exam and expect to get a non-functional, a non-logarithmic or a non-exponential function. You can get those. So what you need to do is to differentiate this function, f of x, and then you're going to go ahead and still perform the Newton-Raphson as you would have in the first place. So go ahead and
Is a differentiation of e whereas e superscript x, that one I'm gonna get.
All right. All right, let me project this one and show you. I'll project this one and show you. Because we did this, but never mind. I'll project it and show you. Remember, the differential of e to the x is e to the x. I keep talking to you and I'm muted. So remember, the differential of e to the x is e to the x. So see, I just push up the first iteration and show you. The differential of e to the x is e to the x.
Oh, so it's still e to the x.
It's still e to the x, yeah. So that you have to go work on. So the differential of e to the x is e to the x. Every time. All right, cool. Start.
Sir, you can scroll up back to the question.
Give me a minute.
Okay.
You want me to scroll all the way up or down?
Up to the question.
Oh, up to the question. Here you go. Nesta, how you stay? You're very silent. T, you finish? Ramesh, you're very silent.
Yes, sir.
Maurice, all right, good. So T is finished. Ramesh, you finished the question? Okay, no response. Maurice, are you still with us? Are you listening in or are you just there? Nesta, how you stay?
Sir, I'm not finished, but you can go ahead.
No, man, I'm waiting on you. Now tell me someone must go ahead. I'm waiting on you. I'm waiting. Go on.
All right.
Hurry up.
Sir.
Yes, Nesta.
So you can go ahead, sir. I'm not sure I understand.
All right, cool, no problem. Come in.
So you sure it's a 3 decimal place or 2? Is it rough for 3? No?
Why I think it's not 3?
All of my answer reflect 2.
Or the answer reflecting 2?
Yeah. But me I work out one more to see if it would actually
All right.
work out.
Work that out quickly. All right. All right, so let me start from scratch. So it says find a
Okay.
solution.
Sorry,
of
that's
F-
fair.
Uh-huh.
Yeah, man. 3 is fine.
Okay, cool. So it says find the solution of f of x, which is equals to x plus e to the x. Do not get alarmed when you see an exponential function. You know how to work the exponential functions. The differential of e to the x is e to the x. The differential of e to the x is e to the x. All right, so, and it says near x equals -1 to 3 decimal places. So it means say, we will start at x equals -1. Because it near it. Work with me. So f of x, which is my original function, is equal to x plus e to the x. See it right here, so? Then f of -1. Where do you get -1, sir? It is near -1. Oh, so then we can use near -1 to mean the first iteration equals -1? Yeah, same difference. Watch me. Wherever I see x, I'm substituting -1. So it's going to be -1 for x here. And then e is going to be raised to -1. You can look on a calculator. You can identify the exponential function. Then you can substitute -1 inside of it. When you do that, tell me what you get. E to the -1 is equals to hello, somebody.
Repeat what you said, sir.
What's the value of e raised to the negative first power?
Wait. 0.31. Sorry, 0.3679.
All right. No, somebody may say, but sir, you know, see it right this, so just subtract 1 from that. I'm going to tell you what I asked. There was a question on the exam paper. It was a McLaren's question. I'm trying to remember. And people were supposed to go and put in values into the exponential function and evaluate it. And I said to myself, oh, them students get this. Mark one script. I said, then how them get that? Mark another script. I said, no, man, I walk on. And then when I grabbed my calculator and I did the question, I never put my parentheses. I said, oh, I got them though. So you need to know how to work your exponential functions and to include them if you need to include the parentheses. I'm making a deliberate effort to do that. And then when you subtract, when you add 1 to it, when you subtract 1 from it, I'm sorry, you're going to get negative 0.6321. And then your f dash of x is going to be 1 plus e to the negative first power. So you're getting the 1.3679. It asks us 3 decimal places, I'm working in 1 more. Always do that. Any number of decimal places that asks you to work in, work with at least 1 more. If you want to work with 5, for your business. But you need to work with at least 4. When I get my f dash of x, I'm going to put that there. Then I'm going to substitute it into my Newton-Raphson formula. Negative 0.6321 goes in the numerator. 1.3679 goes in the denominator. And this negative 1 is where my x1 is. So that's my x1. I'm going to evaluate it. I'm going to get negative 0.5379. This don't look far off, you know, because it did say that it's near negative 1. So now I'm having something that is between negative 0.5 and negative 1. So I know that's where my value is going to lie. That's my x2. I'm going to go with my third iteration. Anywhere in the set function I see x, I'm putting my second iteration to evaluate the third. I do that, I get negative 0.0461. When I substitute it into the original function, f of x function, and when I substitute it into my f dash of x function, I'm going to get 1.5840. When I coordinate, I know that this is my this is my first iteration. This is actually my second iteration. It's supposed to be x2. So my second iteration is going to be that. So I'm substituting here. I'm going to get negative 0.5670. Not too far off from where I'm going. So I'm getting closer. Negative 0.5. And it says 3 decimal places. So 3 decimal places is going to be 538. And this is 567. So I'm still far off. So I need to do another iteration. Ramesh, you see that point? I can only stop my iterations when my values are where it's supposed to be. So because these values are off, I know I need to do another iteration. Unless the question says you do only 2, right? Unless the question says do only 2. This is x2. 670. So I'm doing the same thing again. I'm using the same original function and the same f dash of x. Only thing that I'm doing differently is substituting my values. All right. I think I did something wrong right here. Why am I not having 0.5379 substituted in it? Oh, I do have 0.5379 substituted. And I get 0.560. Why do I not have 0.536560 substituted here? Is this supposed to be 0.5670? Yes or no?
Why is there not to be sure because whenever I get that the x3 my x4.
So my x2 is what I'm substituting here to get my x3. Having got my x3, I now need to substitute my x3 into my x4. So this is supposed to be 0.5760. I don't know what it is that I was doing. 0.56. You need to evaluate it and tell what you give for the answer, please. was copying and pasting this one. Two, four, three, four, five. Somebody talk to me now. When I see you're not doing this, and I know that you're not doing something there.
Yeah, me can again, na. I thought it's square. I looked at my experience. It's square. Let me try to record that we have.
Two, four, five. Two, four, five. It's not 1.5, 1.5, 6, 7, 2, 5, 6, 7, 1, 5, 6, 7, 1. Yeah, so now that I'm finished, because my fourth iteration was not correct, now that I've done my fourth iteration, I'm getting my 0.567, negative 0.567. In the third iteration, I got negative 0.5671, 0.5670, and in the fourth iteration, I'm getting 0.5671. So I know that I'm now finished.
All right, sir.
Mm-hmm.
Here's the funny thing now.
Mm-hmm.
So, 7 iteration, you go. 1, sorry, 3, 4.
Hold that thought. Speak now.
So 3, 4. This time. 5 wrong, but you still get by the same answer with negative 0.567 with 6 and 7.
So you got back the answer that I have?
Yeah. Well, I put it to 5 decimal place for them last two days, so I could work it back.
Yeah, but I don't want you to go to 7 iterations. You're wasting time, and that time could be used to do other questions.
Make mistake with 3, 4, and 5. Yeah.
Or you stay, the rest of you?
Good. Okay, so.
I know this one was a little off for you, and I will tell you why it's a little off, because you had an exponential function. What I find is when I give the question straightforward, box off that. But when you're supposed to sit and think a little bit more on the question, it seems to puzzle you. And I want to get that, get away from that with you guys. I want you to be able to see the question and work it, work it, work it. Don't be afraid of working the question, man. Don't be
Yes, sir,
afraid of,
that's my challenge.
yeah, man, don't be afraid of working the question because you know what to do. And you see the thing about it? Not because it's a fast track class, it means that I didn't know what come on the exam. It's the same thing. So even though I can give questions like the last time around, some of my questions came, but some of CCCJ's questions came. So you have to just boldly attack the questions. Don't be afraid of it. Don't be afraid of the questions. You've been so hungry, hungry. Don't be afraid of the questions.
So yeah, I forgot to do some with Ellen and Knight and
Yeah,
Lord.
man. Yeah, man.
Yeah, man.
Yeah, man. Yeah, man. Now that I know what the challenges are, yeah, man, I'm gonna run with it. I have to get those out of the way because guess what? This is it. This is it. We need to leave Excelsior's bachelor's now and move on to the master's so we can't fail this course again. All right, let me see if I can find one more just for the road and then we top it off. All right, so number 2 there. Did we do number 2? Did we do that? I doubt it. Hello?
No, sir.
No,
All
we
right.
didn't.
All right, come, start.
Can I carry everything up on one side for this one?
I would expect you to. Yes,
All
sir.
right.
Thank you. Thank you. Or we still finish?
Yeah, man.
Everybody?
Yes, sir.
Thanks to TT. Next, Boo.
No, sir.
We're not finished yet, sir.
All right, now give you 2 more minutes. The rest of you look over in the meantime. I'm just waiting on the others. Thanks. Come on, come talk to me now. Ready?
Ready, sir.
All right, nice. Let me disconnect this one here. All right, so let's go. Give me the equation, bam. My first iteration is 0.5. Agree?
Yes, sir.
My second iteration is 0.8181. Agreed?
Mhm.
No?
Yes, sir.
Well, 818.
8188.
Yeah.
My third iteration is 0.7723.
Yes, sir.
702, yeah.
Good. Nesta, me not hear you. You know, Nesta, Ramesh, me not hear you. My fourth iteration is 0.7709. Boy, but let me can't stop.
That's in total. Where you going?
0.7709.
Yeah.
So I don't need to do another iteration because 0.77, my third iteration is, sorry, my fourth iteration is 0.7709.
Yeah.
And my fifth iteration is 0.7709. How many decimal places they asked us for?
2.
All right, so it means that I don't have to go to the fifth one. Since it's 2, stop right. How many there? I don't have to go to that because my third iteration is 0.7723. So to 2 decimal places, we pick 0.77. After 0.8181, we get 0.77. And the fourth iteration to 2 decimal places is 0.77. So my answer is going to be 0.77. I went to a fifth one, but I didn't have to. There's no need. The values are so close. There's no need for another iteration. So to 2 decimal places, your answer is going to be 0.77. Agree?
Yep.
There you go. Questions? Nestor, Ramesh, I didn't hear from the two of you.
So when you rearrange your equation, you have plus 2x
Minus 2x.
So, sir,
Oh yeah, I'm gonna have plus 2x when I do. Yeah, see it right there, plus 2x. Oh, that was a problem.
yes, sir.
Mr. Boo,
Yes, sir.
talk to me. How you stay?
So I didn't reach the fifth iteration.
But did you get the others? The 0.8181?
So I got 2 of them.
Not bad. All right, do me a favor. I'm gonna give you a 10 minutes break, and then I'm just gonna come back and just play around with some differentiation as a little recap. All right, so I'm gonna get a 10 minutes break. So go and go stretch your leg, drink some water, get a snack or something, and then we'll come back to the last. And I may spend about half an hour after the 10 minutes break. All right, so 10 minutes. Stretch yourself.
Okay, sir.
Cool.
Are we back? Are we back?
Yes, sir.
So TT's here. Rashi, Ramesh, Nesta, back?
Yeah, man.
All right, cool. Nesabo. Let me see. She's on KFC. All right, she join us when she comes back. She can just keep healing. All right. So what I want to do is as I said, I'm not too worried about the Newton-Raphson. I know you guys know it. I'm not worried about it. I have seen the mid-semester and I saw the final exam. I need to assess where Maurice is at. And there is another student that didn't do calculus 2 with us, who should be joining me. I also need to assess her, Allison, and I also need to, but I know where you guys are at. What I want to do is also play around now with some differentiation, just to get us to where we are, because you know the Newton-Raphson is an application of differentiation. It's an application of differentiation. So if we're struggling with the differentiation, we're going to be in serious waters. We're going to be in serious waters. So let us see how best we can look at that. So the differential of e to the x is e to the x. The differential of e to the x is e to the x. It means that when I'm finding the differential of an exponential function, it is going to be the exponential function itself, and then I'm going to differentiate the function and put it up top. So what do you mean by that? You will soon see. I'm getting there. So e to the x, when I differentiate it, I'm going to get e to the x. E to the x, when I differentiate e to the x, I'm going to get back e to the x. The differential of the exponential function is the exponential function itself. The differential of the exponential function is the exponential function itself. The differential of the exponential function is the exponential function itself. The differential of the exponential function is the exponential function itself. The differential of e to the x is e to the x. The differential of e to the 2x is going to be e to the 2x. See to yourself, e to the 2x. But I now need to differentiate the 2x. So when I differentiate the 2x, I'm going to get 2. And I drop the 2 right here. So you see that, Rush?
So basically what is done, you differentiate the power, carry the differential of the power in front of the e, and then keep back the the power as the same.
Mm-hmm.
All right.
Mm-hmm. Yes, sir. Yes, sir. The differential of e to the 3x. The differential of e to the x is e to the x. So therefore, the differential of e to the 3x is going to be e to the 3x. See to yourself? E to the 3x. But I have to differentiate the 3x. And when I differentiate the 3x, I'm going to get 3. So I'm going to put the 3 in front of it. So I'm going to end up with 3 e to the 3x. You see? Hello?
Yeah, man.
Yes, sir.
Yes, sir.
Mm-hmm. Y equals e to the x squared. The differential of e, the exponential function, is the exponential function itself. So y equals e to the x squared. It means when I differentiate it, I must have e to the x squared in my answer, see here? E to the x squared. But I don't need to differentiate the power. And when I differentiate the power, x squared, I'm going to get 2x. See this up? 2x. Drop it right there, so 2x. Write this up. Write this up. Watch this now. E to the whole heap of ugly something. When I differentiate it, I'm going to get back e to the whole heap of ugly something. Then I now need to differentiate the ugly something. Differential of 3x squared is going to give me 6x. See it right there, so. Differential of 5x is going to give me 5. See it right there, so. And the differential of a constant is equal to 0. That is it. You tell me if that was difficult.
Without knowing. Yeah. Knowing no. No.
Right. So you see what I have here? I have something that says it is the differentiated power times the given exponential function. Differentiate the power, put it in front of it, times the given exponential function. Work on that one for me. And guess what? It's now 22. We're spending 10 minutes, no more than 10 minutes, to just warm up ourselves with this differentiation. All right? E to the x squared over x plus 5. Sir, not a problem. The denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator, all over the denominator squares. Now hear me out. I don't want anybody to say, sir, you're moving too fast. This is a fast track class, and based on where I would have assessed you guys to be at is what it is that I'm going to go through. I spent some time on Newton-Raphson, yes, I know. But I needed to start somewhere. I know you guys are comfortable. Try that one for me, please. The differential of, go ahead.
Sorry. So for the exams that you want us to do for the x, like what do you do with that?
And what?
So x squared, like
Mhm.
do you substitute the x for something?
No, ma'am.
Okay.
What are you talking about? This one here, number 6?
Yes. Okay.
So the differential of this function is a function itself. So your answer will have e to the x squared over x plus 5, but you have to differentiate now the x squared over x plus 5. So I was saying to you that is the quotient rule. Remember the quotient rule? So you have to use the quotient rule in order to get that piece done up. Rashi, sorry to disturb you, but there's a quick question. You there, Rash?
Yeah.
I have a tablet, you see, and apparently it fell, but of course nobody wants to own up to it. And it keeps moving up and down, shaky, shaky, shaky. Is there something I can do to get rid of it?
As in the screen jumping.
Mm-hmm.
That sound like maybe the touch gone bad. So you probably have to change the digitize on the screen. The screen crack.
But funny enough, I don't know what I do a while ago, and it stopped shake.
Probably the
Strange.
touch gone bad. They might have to change the digitizer, but get a second opinion on it as well.
So I'm changing if I know tablet, and tablets are cheap nowadays. It's another one new one, don't.
Yes, sir.
No, I'm just saying that they oh, it starts shake again. No, the tablet, it just keeps, it's shaky. The screen is shaky. And now I'm seeing some lines on it. So I'm not sure say that maybe the touch is on bad, or maybe one of the cells didn't get damaged.
What kind of tablet, sir?
It's a China tablet.
The inch. You know the inch?
Oh, sorry, 10 inch.
So we can set you up with one. I sell devices and stuff.
Yeah, you do them things there?
Yes, sir. I'm a businesswoman.
All right, then. We see stuff again. All right, we go finish this. We talk.
All right.
Okay. Obviously,
Got two answers, but think they're wrong.
the denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squares.
Should I get a fraction in the end or a whole number?
Let's say let's go through the differentiation. X squared over x plus 5. The denominator, see to yourself, hold on. The denominator x plus 5, see to yourself, the denominator times the differentiation of the numerator. When I differentiate the numerator, I'm going to get 2x, see to it, times the differentiation of the numerator, minus the numerator, minus x squared, see to yourself, times the differentiation of the denominator. When I differentiate the denominator, I'm going to get 1, see to yourself, all over the denominator squares, x plus 5 all squares, see to yourself. Then I'm going to say 2x times x is 2x squared, 2x times 5 is 10x, and minus x squared times 1 is minus x squared. So 2x squared minus x squared is x squared, so it's x squared plus 10x. And then I can factor out an x, so I'm going to have x times x plus 10 over x plus 5 all squared, and that's my answer.
We get the one above the red, but
Remember, it's over the denominator squared.
so it's supposed to end at the denominator squared. Okay, so I should just factor this out. All right.
Just square it. So not look at what does that mean. If I start with x plus 5, then the next line is x plus 5 all squares, it will change. X plus 5 all squares, it not change. X plus 5 all squares, it not change. X plus 5 all squares, it not change. The only way to change is if you have something new and you can cancel out.
Or one of the
One or both.
power.
Yeah. But I'm going to end here. You did well. And with the first class, today's class was really to just galvanize us so we can talk about meeting. So we agree that I'm going to speak to them on Monday. We agree that we're going to have 2 hours on Friday. And I believe I'm going to need some more hours. So I may keep this class as it is, but just to do 2 hours on the Friday. So I can safely say that see you on Friday.
What time on Friday, sir?
I would say 5 o'clock. I want we can get it over with. Or is it at 7 o'clock is best for you? Which one?
Sir, I prefer the 7 o'clock.
You prefer the 7 o'clock?
Yes, sir, but I'll work with it, whatever, but that's what I'll prefer. So I can rest after my half hour.
Okay. The only thing is that maybe I'm gonna have an 8 o'clock class day. Now let us see that time. So we have an 8 o'clock class at on Saturday morning, and then to come back in the afternoon for you guys. It's a push. But there are only 7 more weeks in order to go. And I just want to make sure that I get you guys where you're supposed to be. Students, hear me out. I'm going to set up your editor stuff. Hear me out. Please work with the progress. Work with it. Make me feel like last summer I had 12 students. 12 of them passed course. You know, here where you are mathematically, you can do it. Come energized, you're good to go. Have every blessings to you, and be good and be safe. We'll talk.
All right, sir. Friday.
So,
Okay, so later.
no problem.
Sir. Sir.